Well, good afternoon, and nice introduction, and thanks for the opportunity. The institution, head of the department, INSAT, and all of you. It's always difficult to be in this kind of a classroom immediately after lunchtime, and especially after the Christmas and the gathering of this sort, not loud enough. Please. Check 1, 2, 3, 3, 2, 1. Can you hear me? Check 1, 2, 3. 3, 2, 1. Audible now? Give me the other mic, otherwise. You are finding it. Am I audible now? Okay. So let me start my presentation. First of all, I'm really thankful for the institution for calling me over, and it's a good occasion for us to present what kind of an applications are going to be practiced in the future, and what is happening now, and what happened in the past. So my entire dialogue the next 1.5 hours is going to be talking about what the space agency ISRO has done during the initial stage. The initial stage, some of you may be thinking that why all is being discussed now, but there is a reason for you to understand those aspects. And what is happening around now? Many of the applications, probably many of you would know that these applications are known to you. Specifically, I have taken some 2 applications which are quite familiar to you, and I thought I will give certain important guidance to you. From that, probably you can pick it up. And the last part is going to be somewhat really interesting to you. And I'll brief quickly. You can stop me wherever you are not able to understand or you are not able to follow me, or if you are finding that I am a little fast, you can ask me to slow down. Otherwise, I would like to proceed through that, and you can stop me wherever you are not comfortable. So let me start my first plan in the next 1.5 hours. I will be briefing what ISRO has done as a space agency in this country in the area of application. I am confining myself to the only Satcom applications. I am not venturing into navigation and remote sensing. I am sure the next few lectures which is being arranged will dwell on that. So I am confined whether it is related to Satcom I have talking. Otherwise, it's only, please note that this is only communication part, nothing other than that. And what you are seeing recently, the last 5 to 10 years, and what currently practicing what I am going to dwell on. The last part is open to you. The foundation is laid in these 2 parts, so that you will also go into the other part. The last part is people like you should take over and start doing that. That's the aim. So the last part to come, in fact I should directly go to the last part. But I'm going to spend a good amount of time because this is all very important for you to understand, so that you will be able to do that. And the last part, I am not going to describe only the Indian scenario. I am talking about the world scenario and what India should be doing it. I am not saying anything. And this is what the Department of Space as of now is trying to achieve. So the first 2 parts are very important. So the first part I will walk through very fast and then go ahead. And the second part I will tell some of the in-depth things I will try to talk to you depending upon your interest. And I will go into very fast, and if you are going to stop in those places, if you wanted to know a little more, please stop me. Otherwise, I'm just putting hierarchy. Most of the presentations are sourced from either ISRO's website or from the manufacturer's website. And these are all available on the public domain, and the references given in the PPTs. Let me move and start with the next slide. The first one, as the first speaker would have told, the very modest beginning of ISRO from the church at Itama, so I don't repeat that. But the way in which ISRO was formulated and the way in which every activity is taken up till today, all activities are to reach the public. It should reach the common man. Every activity, in one way or the other, it must be relevance. One of my senior officers used to tell me in ISRO, in India, 20+ years of experience in ISRO, the day we lose touch with public, we get forgotten. So every one of us have been taught in ISRO that whatever we make, ultimately it will reach the common man. Look at the first application, what was happening in 1975. 1975, after the ISRO was formulated, and the way in which the activities, I don't want to read out, but the important point I wanted to tell you this particular slide. In 1975, when we started in a very formal way, we picked up a satellite from American and we did a program, that is we means I'm talking about the ISRO, did a program to ensure that the satellite technologies are directly useful to the farmer. This is a program which we use to 2,400 villages. It's not that we brought those kind of, these are all the technologies where even radio is very new. And television is something which is phenomenally a good unit and good mode of communication, which is being used for going to the villages. And it is not done by only ISRO, and it is done with the several departments which is connected with that. And they did all of them. The main point is to look at the studios that were established and the kind of bands that they have used. This is all I will come to you at the later part of my discussion. We went to the 2,400 villages and established what is called today calling as the direct to home. Similar to the technologies it was used. But you look at the antenna diameter, the 3-inch parabolic antenna. This is the kind of technologies during those days. We saw black and white on those days, but still it was quite phenomenal effort with the borrowed satellite. The focus of our founding father of our ISRO, Visvesvaraya, took this lead and it triggered the tele-education broadcasting. And next slide. I just wanted to take note of all these things to you. I don't want to again read out. Look at the kind of experiment which is being done in the world. This is one of the largest experiments which is done in the world. I'm talking about still in 1975-76, and this is a kind of a very impressive kind of an application which was thought about. Why I'm trying to say all this thing is, in today's arena, when every one of you are going to take it up, just compare what is today and what kind of technologies we should bring in from the UVCE. In that sense, I am trying to tell you that during those days, where the television is something very rare commodity, and people have taken to the grassroots level. They have not worked with any corporates, it's not worked with any other entertainment industry. The kind of activities what we did is the grassroots level. And that is where the 70s we have used this kind of application. In the last two bullets are very, very important. We did certain work with the scientific element as is listed. This is all the kind of data which I don't want to go through, which is visible to every one of you. And the last two bullets are slightly extended from that. After completing the American satellite, we got another opportunity with the Frank-German Symphony satellite. Again, we continued from that. The first part was only television. But then in the second part, we started working with the very postal. Is it loud? No, sir, it's not. Is it audible now? Yes. So, the last two bullets are very, very important. The step. After the site experiment, site is one of the very famous experiments which you will find very large number of information on that. And the site was totally focusing on the television related, how this can reach the common. But when we went into the step, it was more on as part of the previous experiment as a continuity. The founding fathers and our seniors have thought that is a need for us to make an indigenous satellite. The so-called Atmanirbhar Bharat today was very well started during those times itself for ISRO. And using that particular satellite, the Symphony satellite, the entire activity in the last step, just look at it that the GSAT domestic communication, how to establish an independent domestic communication satellite, how to enhance the capabilities and experience in design, manufacturing, everything you need a first hand, what you call as an on-the-job training in recent methodologies. All of them were experimented with a live satellite and good German Symphony satellite. So there are two aspects which I wanted to tell you. In the experiment site, we all in the first site, we have only concentrated on how the television technologies One, two, three, yeah. Okay. In fact, I wanted to tell you, this was not a problem. All my colleagues in both the project, they have experienced more than the technology, how to get them other how to establish a support system. These were all right. Mine is a very small issue, but my colleagues there, all my predecessors have struggled so much. Some of the experiments, you can ask Irene said, some of the late part of it, she was totally associated with the UVCE program. It's always difficult to establish, very easy for us to just walk in and use the computer and try to do. But the experiment what they have conducted in those villages, they were not having facilities. So those things are not they have done. Coming back to the program, site was focused on television, and the step was focusing on how to create a good domestic intelligence satellite system. Everything, right from making the satellite to make it usable for it. So these two experiments are landmark experiments. Next slide. And we continued with that, after seeing the both the success. We went on to the tele-education project. This is one of the projects we did in Gujarat itself. And that we started introducing the interactivity. As you know, like leading edge, most of the system in the first two projects was the one-way system. And we started introducing the interactive system. Then we wanted to know the last bullet, the villages that involved, look at the kind of topics is taken in the 70s. And we were really talking about what are the things which you are trying to do with the satellite. But look at the kind of activity which is doing that. This is the third important project in those days. And next slide. This gave birth to, by the time when we came down to this particular program, we had functional satellites from the INSAT class of satellite, the Geo-stationary satellite, we were able to get owned and owned by us. National televisions have come into place, and the project started as a development television, training and development channels. The site experiment which was focusing on television, and the step experiment which is focusing on how to build the satellite right from the beginning to end. Is all experiences were gained in these two programs. Based on this, there was a KCT project which was introduced the return channel and then went on to the third. And the fourth one, by the time when we came to this developmental telecommunication, that is training and development communication project, it was taken at national level. Having seen the success in all the three, and some of the first three projects we got UN recognition, and UN itself took India's case as one of the best example for emulating in the world. So those credentials were available in the first three projects, and the TDCC project was subsequently taken up, and this is what during 70s and 80s up to 90s, we went up to the next slide will come up to the 90s, and after the 90s, we were very clear in our thinking process that whatever we do with the satellite communication, we should reach the common man. And this is achieved, and it transformed the television broadcasting from the interactive mode of communication to the all aspects have been taken care in these three programs. The next slide. The last one in this state of the series is what the Jaguar development project. This also happened near to the Andaman, and all these four projects. Go to the next one. Next. I summarize here the four projects what we try to do. The initial communications in this country, with our very good planning, we were able to put to use to the common man in the rural area very efficiently. And this is the one which I wanted to tell you. These particular activities were carried out in this country. I don't know how many of you are familiar. In this country, for riding a bicycle, we had a license, and we had a license for keeping a radio set in during those days. from those days, people have experimented cutting edge technology. I should say, in those days, this was the cutting edge technology. In spite of the teething problem, in spite of everything being fine, always this kind of a teething problem will come. And the kind of problems which we faced on the ground is more than technical or other logistic issues. But in spite of that, people continue from ISRO and see to that this is the end objective is spent. And these all aspects have been factored, and the Indian National Satellite System, the INSAT system, was established not as a project from ISRO. The project was funded by Department of Telecom, Meteorological Department, and the Telecommunication Department. All of them together, they established a common system. The INSAT first few satellites were only by the user agencies, and they were involved, and that is what is being done. So this application, why I am trying to bring it out as a part of your memory, is that this is done in India by our own people. And remember this, and when we go to the next and the last segment, and I will summarize them at that particular time also, that right from the start, the word go, this is the kind of an application that we have used. I should call all of them as a killer applications. Let me move to the next set of activities. Next slide. I would like to brief you a broad kind of applications that we have come across till now. Many of these applications, you and me are using it every day. Maybe it may not be directly, some of them directly, some of them indirectly. And majority of them are known to you. Some of them I am going to dwell little depth, and some of them a little bit more. And at the end, I will be talking about how the future is going to be. Starting with the television services and DTH, I will cover in that. But the television services in this country, we started initially with the C-band. And I'm sure that in the previous lectures, by now you will be quite familiar with what kind of the bands that we use in a satellite. And predominantly, the television services were in C-band, and majority of the TV channels were in the C-band. And we went into the DTH I will cover it at the end. That is about the television services. And the multimedia delivery was also possible, and it is happening through the GSAT kind of application, which probably you will see here. This is a two-way services, but whereas the direct-to-home, which many of you are familiar, is a one-way service. So both of them, foundation stone is only these two for the satellite communication. In a sector one, where whether it is a banking application or ATM application, the GSAT comes to the picture. And if it is a direct broadcasting, which I was referring to you with respect to our Satcom satellite or ATS6 satellite, the newer version is what you are seeing. Probably we used a different band, but whereas when we come to the DTH, we use the KU band. Maybe the advantages and disadvantages as we go along, we'll just try to brief. Already has been discussed in your previous lectures, but still for the continuity, I will touch upon that. So the television services and GSAT services, the basic distinction is the one-way and two-way. And the derivative, using the GSAT service, it is possible to provide the multimedia delivery as a one-way delivery or a two-way delivery. And internet also there is a one-way delivery, and we will talk about that little as we get along. The mobile satellite service is one of the very important application. In spite of the best efforts in several decades, we were not able to bring out commercially viable service. That's why we continue to use the data of terrestrial mobile phone. And to talk about the mobile satellite phone, the market, according to us, is going to be a very tough market, and it's going to be difficult to achieve. When I say certain things difficult, it is a challenge for every one of you. I put that at the end, what are the challenges that you should be facing. And we find it becomes difficult. And we will touch upon the points of difficulty. But if the mobile services are existing today, it is existing to selected sectors, but it is not from the way in which every one of you would like to do that.
Mobile satellite services, would you like to touch upon the challenges, is whether it is a technology challenge or the regulatory challenge?
I'm coming to that, sir. I just, in the earlier slide, I'm just only touching various aspects. Some of the things based on your interest, I will take it, and I'm going to touch upon the mobile in depth a little bit. And here probably you must know there is a satellite radio. It was a very, very important. Prior to when we were talking about shortwave and medium wave, And before the birth of FM channels which you are nicely trying to use it now, it was not available, and satellite radio, the Cyrus satellite radio in the worldwide and world space are a good satellite based digital audio broadcast, a very good quality sound. We were thinking that that is the way in which it is good. Unfortunately, it is not gone, but still functional satellite radio services are existing in the world. At least couple of them, world space and Cyrus is functional, and any one of you who are interested in looking into that can go to the web and try to find out. But it's not going to be in the arena of FM broadcast. I don't think that that's going to be a viable option, and that's why we have not in this country proceeded with the satellite radio. And strategic services, when I say strategic in multiple, one is armed forces, and any disaster when it is happening, and the way in which we try to achieve terrestrial technologies are not going to be that relevant to you at that particular point of time. There are plenty of cases where we can prove it is only through satellite that we will be able to provide instant connectivity and foster activity. Of course, terrestrial will add to the value, but satellite is going to be provided. So when I say strategic services, the search and rescue are going to cover a little bit more, and disaster and other activities are very, very important, and I will cover all of them. And navigation service is important, I am not going to cover, and the next lecture they are going to talk about. Please listen to the navigation area. It is as big as the Satcom, and the revenues are going to come hugely from navigation services. If you talk any location-specific application, it is contributing a lot. And when it comes to the society, this is where the government-based system, that is from the ISRO, we took a lead, and the few slides which I presented during the 70s continue, and some of them I am going to dwell for your own understanding, and some of them I will go a little detail, and depending upon the time I will skip them otherwise. And these are all the activities which probably you will come across. I try to summarize many of the Satcom applications. Every one of them deserve their detailed look at every one of you. And as you, this is all relevant as we enter into the next study now. And many of you, after your completion of the course, when you get into the job market, and you will be looking at it. And my intention is that at the end of the lecture, when you start looking at the papers, you will be able to understand better, and you will be able to go in the depth of your interest based on what has been done by ISRO. And this is not an exhaustive one. You have all the linkages to the links I will be providing. Now let me briefly touch upon. I picked up this application because it is most familiar to every one of you. I don't think that anyone, I hope DTH is known to every one of you, and you have been using it across. This is one of the very popular applications worldwide. It is not just in India. It is a huge revenue earning potential. In India, we started with 2003, and today you look at the data. This data is taken from the Telecom Regulatory Authority of India's website, 2021. Look at the number of channels that is being operated. This most recent data, 22 December, they will publish. This is the most recent data available. And in India, we are able to get, that means that these many consumers are available in India. Maybe manually is the highest consumer market in India. Otherwise, probably we don't know how the Chinese are using the direct television. But looking at 2003 to now, a good number of revenue has been earned, and that is your money and my money, which is going into the Satcom system. So the revenue earned here was quite phenomenal, and none of the ISRO persons are involved in that. The market demand itself into. It's a popular application picked up from the various, and ISRO provided the satellite for them. It's not only ISRO satellite, foreign satellite also was operational. But the point which I am trying to tell you here is that this is one of the major applications, and here what I wanted you people to understand is that we were talking about MPEG 4 and DVB-S2. The way in which the technology evolved was initially it was a DVB-S format, and afterwards it went to DVB-S2, and it is now DVB-S2X. So the technologies that is associated with that, most of them are imported. Even today, if you see, majority of them, I don't think that any Indian system is available. Either you embrace the European system or a US system. And these were all very difficult because the electronics industry was not enabling anyone to make it. But today, it's available. If you wanted to make a DVB-S2 based system, it's quite possible. And there are very, very small startups. I should not say startup, they have established the systems. And it is a good idea for everyone of you to concentrate how the DTH is functioning. And if you try to go into the system, it will be always possible for you to understand and make a system and how we can make a derivative. And that is my another job which I am going to do. How we still innovate the system to make it still functional as we speak today. In fact, I forgot to tell you one thing. In the TDC system, though it was started in the 70s, even today, one of the channels being run from Mysore, Abdul Visvesvaraya Institute, is running for Karnataka the data system. Even today it's functional. It's working on the external band and it's still functional. So the DTH still it is functional, but I also wanted to tell you, to be very frank with you, I don't think the DTH, you also will agree with me, is going to survive the way in which it was surviving all these years. There were maybe 4 operators or something, I will just summarize them. Only 4 operators are there. There were about 7-8 operators were there initially in the DTH. There were players, there were people like Videocon, many people were there. But 4 people are right now, apart from the Doordarshan. The PHN operators are 4 and the DTH is, Doordarshan is 1. With that, these many consumers are there. With the end of Netflix and many aspects are coming, demand-based videos, demand-based channel, we also find that it may not be surviving to the extent it was done during the initial years. So that is what I learned. The terrestrial technologies are going to come in, but you please remember, today fiber is going to your house, you can always go with the networks. Just imagine our country, rural population, how they are going to take care. But the rural, speaking at rural, we cannot keep on running very powerful satellite because the cost of making the satellite and trying to run is going to be very, very difficult. It's not going to be easy. But you have to note a point that time has come where DTH may not be the de facto like the way in which it was, but it is going to be relevant, and that's what is happening even in the US itself. And to the extent of growth, what we are seeing is not going to happen. Explain. And another second bread and butter is an interactive application, a very small aperture terminal. This is provides two-way terminals. The kind of activities which it can support, I have already listed. These are very relevant in the past, now, and it's going to be in the future. It may not be called as a VSAT, but these VSATs are going to remain forever. And again, here we are now nearly 2.94 lakh VSAT. You can go to the next slide. This is the general activity. From the activity of INSAT 2C, ISRO started providing the KU band, because KU band we find that it is cost effective, it is as compared to other bands. And we are putting up these many satellites, and it's going to grow, it has grown in that manner. Today, about 3 lakh VSAT. Basically, to talk about the VSAT, what band is going to be placed, is you can see it in ATM. Majority of the bands, they use them. And it is still relevant, and I will tell you when I go to the next segment that how it is going to be very useful. But remember, every one of you, if you are going to be in the satellite communication sector, you will be dealing with one version or the other version of this kind of an interactive VSAT, either at your home or colleges like this. It will be part of that. Even the new generation, smaller satellite clusters that is come also, this is going to be very, very useful. And here, I wanted to draw your attention that any one of you who are going to work with the satellite models, you will have to look into this growth, how it has gone over the years, how it is going to be useful. So the 2 applications which I picked it up, ISRO has no role, and it is only enabled the satellite capacity. Majority of the equipment which is setting up is done in the private domain, and we do not have anything done in India, including some places even dish is coming from abroad because of various aspects. And both the services, a huge revenue. I will be talking about revenue also. Look at these 2 services, which is every one of you. I took these 2 applications to explain so that it gets registered in your mind. That these 2 applications needs a relook today. How we can take these 2 applications to the entire world with a combination of other technologies. So I will stop at that particular point with respect to the VSAT and the DTH, and we move on to the next one, please. And related to that, I was asking That's why I just introduced this slide. My intention, those two slides that take up a volume market which is going to fetch a huge revenue around the world, not just in India. When we talk about the satellite, you know very well that there are no competitor fields when it comes to providing in-flight services, that is the aircraft. And maritime. You know the kind of maritime applications which is the ship. The entertainment ship which is going and cruise which is going, is only satellite which is going to play an important role. And the third one is the disaster management. This all of them, there is no competitor. Only in land we have a terrestrial which is cheaper, which I don't deny, and you should embrace. When what is not being achieved, what cannot be afford, we cannot afford in that particular segment, only will come to the satellite. But this particular on the move, we have an edge. We always have an activity which can be connected, and many activities are done in this particular. Unfortunately, we are not able to get a commercially viable system. That's why today you see a DTH, you see a GSAT, but you don't see a satellite mobile. In power which is going to be still in the hands of air security agencies or selected few who can afford, blessed by the government. Most likely, most of the time it is by the state disaster management agencies. The reason, I will touch upon here at the end, I will little bit of detail I will give. The one thing is that the band that can be used for this is two bands, that is L band and S band, which I will cover in specifics. It's all affordable and proven technologies are available. But to make the handset, to make the matching satellite and to make it as a commercial form, it is not working out. Because it's not volume market. We were able to do it in DTH, we were able to do it in INSAT, we followed the world trend. But when it comes to the satellite mobile, it is not coming as cheap as this because of 2 to 3 aspects. Number one is, as of now, the L band and S band is only 2 bands, and that is very difficult to get it allotted to you or to acquire it, and it's a different process I will tell you. When I say acquire, keep it in inverted commas, how to acquire is an issue. So these 2 bands are an issue. And second thing is, first of all, it should be available to the country. Second thing is that when you make it in volume, you will be able to produce in mass quantities, then only the form scale is going to come. And because of these 2 aspects, coupled with regulation, they are very tough regulations because it can be used for good or bad. You know the mobile attack, majority the terrorists are using only the satellite mobile. But in a way, you know, we track them down because they were using the satellite, but the visible signatures were available. And it was possible for us to do for both the application. And there are applications like Thuraya Communications, which is active now, which is providing the satellite around the globe. And there are a good number of world-class satellites are available, but we have only few satellites in that particular category of S band. We do not have the L band. But if you can concentrate and try to improve, compared to the days where we were working the last 2 to 3 decades, some things have improved. There is a possibility, but it has to come from like the way in which INSAT and DTH came from the industry, worldwide market. You should embrace, and someone has to come and put the money and push through it and then try to get it. It is not impossible, but it is an area where I will, when I summarize, I will try to list this. But keep it in your mind that as we discussed about the direct-to-home, interactive INSAT, this mobile through satellite has a good potential. Looking at all the land mobile, aero mobile, land mobile I will leave it. Land mobile is coming only during the disaster management, otherwise we cannot compete with the kind of price what you are going to get. You will never achieve. I would say, normally I am not supposed to say it is impossible. But the challenge is to you. If you can make it, it is very good. Innovation can come from anyone sitting there. And the land mobile is going to. But we are a king in satellite-wise, aero and maritime. There is no doubt.
Sorry. Batting on the same side. Foreign satellites at Iridium, Inmarsat are available and they are working, they are functional. But I think the regulation prevents people, common people, from using them for the satellite-based mobile communication. isn't it?
So, there are two aspects, sir. One is that the one ATM and all of you always satellites. Geo-stationary, right? And they are somewhat, the way in which it is started, like our S-band movement thing, they are somewhat defunct. And now they are activated. And they are using it across. So they themselves was not steroids. Otherwise, Americans would have bought in a bulk. Even in US, the ATM satellites are not that much used. But it is true that INSAT, the demon terminal and all of that, was extremely useful. Because it was a functional service even today, like the way in which we are talking about DTH and GSAT. Similarly, INSAT is one of the good examples. They were being providing for the air traffic completely is provided by the INSAT airline. So they were having a very good number of aircraft which are covering it across. But it is not possible for us to get this one aspect of that. But the issue is it has a dual use. It is not allowing them. It can be used for any other purposes. That is where every country has got its own intricacies associated with it.
Basically, what you're telling, because of dual use, the regulations, the government regulations prevent common man from using it.
One aspect of it. Cost is, the people, for example, a CEO of a company, don't want to take their names. If he wants to, he can have, he can buy. But today he cannot buy in India, that's all it is saying. But of course, if the ADM is ready to give 10 cents to a company, and he's not able to buy, that's all what he's talking about. The regulations we are not allowing, because that's why I brought in a little bit of, the Bombay attack. Bombay attack, though they have been using, we have certain capability to do that, and because of that we got into. Same thing is true, because whatever we are going to do, it is not going to be protected. But not necessarily that it's absolutely necessary for a country of our size, as well today, the way in which we have grown. There is a need for us to have this in our country. Today, for some of the aid of three things. One is the regulation, which is easy to touch, not an issue, which will be possible for us to do. The basic thing is that the LM base is stopping us. There are some emerging maths which I will be talking about. Hopefully, as the days to come, maybe 5 to 10 years from now, when I meet every one of you anywhere in the corner, probably one of you will be working on that. That's a hope which I have. So that's the thing of the thing. The third. Let me go to the next few light subjects. These three things, please remember. I will come back to that. Everything system that I talk about, I will visit. And now I will take a deviation from here. Talk about how ISRO was involved in incubating some of the application. Next slide. One of the application is we were thinking after completing many of the societal projects, we were thinking the government, the then government also was of the opinion that we need to do something for the education sector. That is where we thought that the technologies for the DDH prior to that and after the arrival of DDH and the GSAT put together, we were trying to get it configuring a satellite which can be used for educational purpose. So these are all the primary aim of the education satellite. And the second point is very important. The program was never aimed at replacing teachers, schools and other supporting area. It should exist as it is. We are very quite clear that the one-to-one touch what we use now should be retained. But we should only supplement it through that. And the way in which we are going to do all of them, on all the sectors, it was necessary. And I would like to take you through some 3 to 4 slides. I will complete this particular activity to try to bring in an opinion to you when you start looking at the new generation application in the current day, how it is going to be useful. Because the program when we started here, the fiber reaching the colleges were very, very limited. Even national knowledge network which is supposed to run the fiber to each and every college was not available. And that is the period in which we started. We thought that we will use the satellite and try to do. So these are all our broad aim. And these are all some of the things, the objective aim. This is all not done by the market forces. DDH and GSAT by the market forces. But here what we did was we picked up these two technologies. We put set of people. We have a full functional unit in ISRO, the DECU, Development Education Communication Unit, which is located in Ahmedabad. Even today it exists. And they and with all our R&D centers have configured a satellite as well as a ground system. So that we will try to use these three technologies, that is direct to home as well as the VSAT technology, to penetrate the primary school, secondary school, colleges and even higher learning. We were trying to use. This all done during the days where the fiber was not available, except IITs, not many colleges had. So these are all the things which we did. The hybrid model is what we were trying to do. Next slide. It was well structured in that manner. The 2004 to 5, we have not made a dedicated satellite. We thought we would first experiment with the existing satellite. That was the phase, and it gave a very good results that it is feasible. We should take it across. And then the operational phase, we had a dedicated satellite which I am going to explain and show right from now. And at the end, ISRO cannot do this activity forever. It's absolutely necessary. The phase 1 and phase 2, we should introduce the technology. ISRO was there with every school and colleges. In fact, even in the entire length and birth of the country, because education being a state subject, everyone will have their own regional languages. So these two pieces are very, very important for us to implement and then hand it over to the state government, and they should go on. Next slide. And this is the satellite which is configured as a Geo-SAT. And look at the year in which it was launched, 2004. And our Giragan sir was the lead person as project director. He gave this particular satellite, he worked on this particular satellite. And this particular satellite was with a specific purpose that we must implement through a dedicated satellite. And we got it onto, and go to the next thing. It has got a 5 years. And to take care of the regional interest in these language-related activities, we were forced to today we are talking about the spot beams, and we were able to implement it in 2004. That means the capability existed there in the way in which the requirements were put to us. The requirement was put the way in which today, I am sure that all this satellite would have landed in that particular manner. But as compared to the national beam, which is covering the entire India, the beams are made smaller so that the region gets benefited, and it has got multimedia content and receive only and video interactive, the receive only the way in which another way of talking about DTH, and video interactive is nothing but another way of talking about VSAT. Next slide. And this is a plate of a network which every state in the country was provided with it, and ISRO was totally into them how to configure a hub, how to make an interactive VSAT, how to configure a DTH. All of them, every state government was taken on board by ISRO, and ISRO was working with every state, and all of them were established. And some of them, working in K-band, it was, especially in the northeast, was very difficult to handle the gain of the data during the bandwidth. In the sense, during the rainy season, you lose the signals, and the temperature and environmental effects are also to be taken into account. So those things are factored, and we got extended C-band also. Extended C-band provides a different level of comfort as compared to KU, and KU is very good in certain places. So both the things were taken. Every state was given one hub, and we were able to activate for the state's use, and it went on very well. And the same hub will be used for primary, secondary, and higher education. Next slide. And this is just to give features of how a broadcast network is going to be, and interactive network is going to be. And the interactive network was very useful because the engineering college students would like to ask the question to a very great extent, and those questions need to be provided through a kind of a mechanism. So that is why the interactive network was kept for the higher learning. But whereas when it comes to the primary school, it was one-way school. For example, I will just take one small case with respect to Karnataka. The Karnataka, there are about opposite to PES college, you might be seeing the DSCRT, that is a place where we have put up a hub for the Karnataka. And it was being to the students of primary school. The primary school, Chamarajanagar and Bangalore, these are all chosen. And all the 883 schools, we have configured a receive-only terminal, and the government, state government, that is primary school, Sarva Shiksha Abhiyan, they made 365 days syllabus, and they have made a document. This document will go to all the schools, 883 schools. Those headmasters will have the entire book available. What program is going to come? how the content will come, how the local teacher can facilitate, and that is the way this was being done in the 3 districts. To that extent, it was a very clean program which was done for several years, and I think now it is they have found it's not that much useful. But if you look at the remote place, this is all not an even in Bangalore in our house we may not have got a good internet link. That's a bit of a time period which I am talking about. And imagine this rural primary school. I will show some of the clips that you will really appreciate. I still remember in one of the sessions, on 1 year's particular session, they picked up a student from a remote kind of school where the person was picked up when he was not even knowing English alphabets. He was picked up and brought to the studio every week, and they ran a session. And at the end of the session, 1 year, the person, the young boy, he was asked to conduct the inaugural function in English. That's the kind of an impact which it has shown. And it's all talking about in and around Bangalore. That's the kind of an impact which it has created. And all are documented, is available. Now it's not available, and I will come back to that. So this is the kind of a broadcast network and interactive network that we are talking about. Go to the next slide. I just put it across, this is going to be available for your access, you can get into that. And we picked up the unit exactly like my friends here they are doing. We were not making a unit which is only usable for us. We picked up, for example, that's why when I saw the Abuja immediately sounded that. What are the available problem-free which the technician can locally handle? Those kind of equipment was hand-picked and they were put on and they were used. For example, those days the handicap was very famous and everyone was going to handicap. And there is no need for any professional camera person to be hired and camera, time filters, nothing of that. You have a common microphone which you are used to it. All of them have been picked. The good level of activity has gone in to keep the cost low. Video line was used to, we have not bought any of the professional software. So all of them put together and handed over free to each and every state government. ISRO funded and asked the state government to fund 50. So it was 50. Some places we gave it 100. For example, there are places like few states I don't want to name, should not become, by stating the name I should not get into controversy. Some states were not in a position to accept this. But it was our duty to push them start using because we cannot leave one state in India to be lagging behind this. So we went ahead and started giving them, and especially Jammu Kashmir, Northeast, name the state, all the states have this particular activity. This is what I was telling. Some of the things you see is all, I just picked up the photographs which is relevant to Karnataka, and many of the teachers are still, they are with us, they are of my age group, and all of them, they are functioning so well. And in case of primary school, to funnily, we wanted to discuss about some of the non-technical challenges. When we start providing the satellite-based communication, we never got a problem with respect to the satellite. We only got, sir, we don't have a cabin. So we kept it there and will come, the noodle scheme will be there, they will put all grains there, the rat will come and cut and that's it out. The so-called annual maintenance contractor will come and say that, sorry, I cannot do it, it's beyond my contract, and they will put there. And then the election will come, immediately they will pack up all the things to one room, and they will come back, they don't know which to connect, what to connect, you don't have the technical people. This is one of the people that still we lack all the implementation. We addressed. In fact, many of my colleagues sat and with the corporate to make a provision that how the RAT cannot enter. It was not a technology. So that is a kind of challenges you may face. And what I'm trying to point out one or two points is the challenges sometimes is beyond your domain, but it's absolutely necessary for us to see overall success of that. That's where the strength of ISRO lies. So these are some of the slides which I picked up in and around Bangalore, and many of them are functional. But it's very difficult to go to this level, but we need to do that. Next slide. And this is one of the primary school. This is the way they were listening, and I still appreciate the whole state government to come out with the entire system. They had a program book on the hand. Sincerely, like an Arab publishing January month, when it comes The work will start and it will go to all the areas and agencies. So I'm talking about one district. We took 3 districts and afterwards they ran on them because our job is only to ensure the end-to-end handhold them and then afterwards they should do. And that is what was being done. They did and we never went into it. In fact, we never kept the update in our premises. Earlier we used to do it in our premises, but we never went into that and they did and ran for it. But at least to my knowledge, 8 to 9 years flawless operations. Flawless means the problems, the mechanism used to be there, but it gets into that. But remember, this is one application that we innovated from the commercially available, the so-called DTH light system and VSAT light system. We never manufactured on our own. Go to the next one. This is the higher education. The VTU was very active, and I still remember Saturdays, Sundays, college used to get very large number of people. The reason is that it's supposed to be in Bangalore, that the time period varying software companies were coming up like anything. One of the CTO or CXO, they call it a CXO, the CTO or CEO will come and speak and they will reach out. And the rural student, the only way to get connected to the good, or whatever they see in paper, all of them, they came and they speak. And that's the kind of innovation which you I also picked it up because I'm not really sure. I thought what is relevant with you. And this video is still available in GSAT. I don't know what form that is. Even the Belgaum is supposed to be a headquarters, but they were having this video from here. It was quite active and in fact education was quite very, very good. And again, the school had got only this connectivity and they were using to the extent, they were not telling us, they were using this handicap for something else also. So it was multi-purpose, but we are happy with that because whatever we put, it should be as a standard. There are many aspects. We also ensure that it can be used for example, this kind of a lecture. You could have used the same system because it is available. It is well structured. We gave a Bosch. We had a microphone which is a very standard Shure microphone and things like that. So we all took care of that, the echo cancellation and things like that. We did a good number of things. But it is happening at primary, secondary, and higher education. That's the beauty of the education here. Go to please, sir. And all we had a good combination when we started. The president was Abdul Kalam, and we had a comparable prime minister also. Both of them were so much associated with that. Personally, they will suddenly get into the network and they used to come and talk. And they know much better than anyone else. So I think there was a good support for the education getting a different level of acceptance by the students using the space technology. These are all the key aspects. So we ran this program in the education strategy quite remarkably well. So to summarize, I just summarized this clearly, and the next few things I will go fast. And to tell you one example of how one application can innovate and how it can lead to many such application. And this one is somewhere in 2010 when I am talking about when the college is not having an internet database. These all things are practiced in our own systems and it's not done at one place, it is done at multiple places. Every state headquarters and this opportunity. So that is about the tele-education. I cover one tele-medicine, which is also quite relevant. As now, let me also tell you, this may not be so relevant today because you have the national knowledge network connectivity and you had a dedicated fiber coming to your colleges. Same is true with many of the engineering colleges. So it may not be needed in this particular form. That need to be a hybrid. So we did not develop a very little extent tele-education beyond even for higher education and primary education still it may be relevant because I don't think that primary is going to reach every primary school that you and we have heard in the days. And it is going to be relevant, but it is up to the call which is taken take care. It's not technology, because technology is available, it's still affordable. DTH, every one of us are having in our house, you know the cost how much it is going to be. And the primary school having this is not an issue. So if the primary school, when it is going to take the connectivity in rural area, I will teach you. You people should try that. So that is what it is going to be. Now next is coming to the telemedicine, let it walk faster. And like a tele-education, telemedicine is also another important what is called a punch it is very important for us to provide, and it is not done during COVID time. It was done much before, and this was done with ISRO's involvement. Then we were trying to talk about the government schools and colleges. Here we thought that we will start tying up with dedicated charity hospital, government hospital, and ISRO coming in the picture. So this is all photos which we have taken. Our idea was to connect the remote hospital to the very super specialty hospital. Go to next slide. And this is all the technologies which was available to us in the education form and UPH form and INSAT form. We embraced broad output in this. And this is a typical tele-medicine concept where the district hospital is getting connected to the specialty hospital. When we took the computers to the hospital, that was the first computer to arrive in that particular hospital. That's the gain of the improvement. Again, it's the tele-medicine network in Karnataka case only I am just taking from. And Dr. Devi Shetty and Nimons and all of them, they got connected. They took on board, and the rest of the doctors used to come and sit for the consultation at our point in time. So this is the kind of the connectivity which was established. And to tell you the basic building blocks, these are all the building blocks from the patient end to the specialist end. Our model of bringing in those days is that bring the doctor to doctor consultation to take place. The remote side at the district side, there will be a doctor with the patient, and he was having an X-ray unit which is quite outdated and things like that. So we told them, we worked with the government to bring a digital X-ray during those days and get connected to the system, and all the X-ray and all the local diagnostic is to be captured in the district hospital, and we engaged the software guys, industry guys to write the software. We inputted some 2-3 industries during those days. And even the DICOM connectivity, the DICOM is the standard it has become, and it is used for the HSL standard, like the way which is HTML standard is there. Medical community work with a very standard class. So to that extent, we work with the medical community to standardize all of them, and those activities that got connected. Go to the next slide. And we had very good number of topologies which you might have come across. All the topologies were used. And we had very good performance here because saving our lives was one of the important things. Only one example is that when we started establishing this in Andaman and Nicobar Island and actually we were finding it extremely useful. And it came as a boon when the tsunami struck. When the tsunami struck, where we have put up in Karnikobar, we had 3 districts in Andaman and Nicobar. The Karnikobar, we have put it up the hospital. And after tsunami, the entire hospital submerged and only we could see the antenna. And the last point is the Indra point is a small village. There we have put up a GSAT to get it connected because there are 500 member village. And entire thing washed off. Only we have only one post remaining there. And during that particular time, this came as a boon to them because all of them used the system only to connect to the internet. Everything is free. We were not able to do even the interaction. But this kind of a system provides very good medical assistance, not only provide the medical assistance, that enable the communication with the mainland. And today, Andaman is connected with fiber, but the problem remains in the actually. There are places where still we find there are issues. So as I said, it is going to be relevant, but it is not going to be relevant as it was earlier. But the telemedicine still, even countries like US, still continue to run a very good number because during disaster, this is only your approach. There is no other device going to come to us as good as this kind of system. As compared to telemedicine, I give a lot of weightage to this particular system, what we try to introduce. One can innovate. Here, all of them are looking very costly, but today these cheaper systems are available. And it's virtually being especially those of you who are involved in the medical education. The post-cancer care is extremely important. The people will go through that in a very bad way. We found it extremely useful. And there are very many activities because of paucity of time and not going to certain instances, but I'll just try to underline how relevant it is even today. I'm not talking about in India, it's going to be even countries like US still continue to run several systems because of the two important things. One is the specialty doctor is available only in city-based. Second one is that when disaster happens, this becomes our rescue. Third thing is that the patient coming from their home to a place, it becomes extremely difficult. This becomes very good. And in COVID, you would have experienced how we can go with this. As I think the patient and doctor, I described the explained in a short of time, so I will not dwell on that next step. This I'm leaving the slides with you. These are all phenomenally a good number of things which needs a re-engineering. When I come to the last segment, these are all job of yours. When you come after you graduate, you can take up a position. Probably you can look into it, and any one of you are interested can straight away concentrate and then try to contribute. And here, the mobile telemedicine is one of the very, very important aspects. I have heard, especially in ICAN, the very well-known hospital in South, told me that they used to go to the village. You just imagine here, a very dedicated doctor is available, and he wants to provide service. And even for him to go to the village, it is going to be extremely difficult. They were taking a bus, and the local Lions Club used to fund them. So the doctor used to go, leaving his practice. He used to go there and run a screening camp. For running a screening camp, what they used to do is they used to bring all the 200 people. They would have a chaluki and place them there, give them the food and screen them. Finally, there will be 3 or 4 infections inside the hall. This is very difficult. But the moment we gave them, they lined up with the Lions Club to fund the petrol, and we took it there, and they have screened it, and only those 2 people could fall the hospital. But maintaining this particular van was a very difficult thing to pass through the road transport authority to height and things like that. Second thing is that when you go into the places, there will be trees. The moment you get hit with the dynamite out. So we need a lot of other issues of sophisticated system maintenance. So that's why I put operational maintenance as a challenge. But still, this provides mobile telemedicine is a very, very important thing. And the kind of activities which is happening in the highways and things like that, there is a need for us to have some kind of a system. Maybe the newer innovation with the operational maintenance we can handle. And I have seen many doctors telling me that it is still a vital effort to maintain that hands-on. We will discuss about that. This is what I was referring to in the mobile, land mobile, and satellite mobile. Maybe this is probably you keep an eye on that. Go to the next one. This was some of the mobile lines. This is what I'm bringing the pictures which is practiced in the more recent times. Some of the mobiles are still active. In spite of all costliest things and difficulties that continue to run, especially Victoria and some of the hospitals are still running. Next. And this is one of the things when there is a COSI inundation happened, they don't have a mobile. So one of the hospital moved the mobile van itself with the railway truck, and they removed the wheel and then they transported, because when they transported this, it is very difficult for them to make it to go through tunnels, and it's a long time. And this is the kind of places where satellite has reached and provided service in the past, and some of them are still functional. Now, I'll quickly go to the third one. We addressed about the education and the health. And the third one, when we go to the villages, we thought that village also needs a very good kind of a connectivity. So we brought in the successful component of the education part. We brought in the medicine part, and we put it in the village resource center along with air conservation data and fisheries data, things like that. We gathered all of them. And in the first model, in the tele-education model, we worked with the pure government institutions and government schools, government colleges. When we came to the telemedicine, we started working with the private charity hospital. And here we tied up with the NGO. So this again, we went to each and every nook and corner of Uttar. For example, in Karnataka, we worked with the Karnal group where Dr. Sudarshan was heading that kind of thing. In Tamil Nadu, we had a Swaminathan that was trying to do. In Ahmedabad, it was the Seva institution. So all of them they are newly trying to help them. And they come, for example, in Ahmedabad, they were running the tele-education, it's not tele-education, they were trying to cater to the women's empowerment, self-help, how to impart the skill education. This is the kind of thing which they were doing. And very many things are happening in this kind of village resource center. This was also done during that particular period. And again, here also, it is quite completely a village. Even I think that many of the village resource center you find the fiber connectivity. I don't think so. These are all the places with the VR and things like that. These are the places we are the around areas only, they were all working that kind of places. And again, the antennas and the configuration, I try to put it across. Next one. The configuration, we try to pick them from both sides of both the programs. These programs are done concurrently. Go ahead. And these are all several services which is loaded to the village person. For example, if you want the fertilizers, we tie up with agency who can provide that kind of information. And we work with all the government department and made the NGO who is very active. Without this tool, he was providing the service. We augmented them. Choosing this NGO was a very tough job for us, but still the team ISRO did that particular work and did that. This is all kind of spread the various states shows what kind of association that we had with very many people. And the telemedicine and village resource center, both of them, as compared to tele-education, provide an equally good service. I would rate the telemedicine still to 11, and village resource center, I will give it to people like you, the next generation people, when you get into the job market. You will try to find whether the terrestrial technology is relevant or still you have to run the satellite. But unfortunately, all these things are not commercially money earning. Someone has to put time and energy to incubate. But whereas DTH, there was a ready market available. Every one of us were choosing operator, but it was available. So there was a commercial revenue. But here, we tried our level best to incubate, but it is a very sustainable agencies like ISRO alone cannot do. So we brought these models to the planners, to the states, to be aware of this. And after that, we backed off. And even leaving many of them to run in their own way. Next. And this is one of the important satellite communication facility, the data collection platform, especially these all unattended operations which is happening like Narmada and things like that. We collect the local data and send it to the satellite. We have an automated weather station available. Unattended, it goes to the satellite and we pick it up. And the meteorological department is going to analyze the data and provide the local weather prediction. Next time. And currently we have 3 satellites which is supporting them, and all of them are doing well, and this is becoming very relevant. And basically, as an application, how the hidden application silently doing the job is what I want to mention here. The unattended data collection platform is being connected to the satellite, and this is being used for providing the quality prediction. As we improve upon these accuracies and adding more parameters being connected with the specialist, you can innovate, but the technology is available. The cost is not an issue, but it is a mandatory. In fact, success of this led us to provide this kind of a thing to our neighboring countries. In a,
Probably you can say, what is the data being sent? In the previous slide, yeah, the wind speed, wind direction, humidity.
See, these are all the relevant parameters which the meteorological department says I would like to have, so that we are able to make a better prediction. So they list out the parameters, and whatever the parameters they are going to list out, they will also identify which instrument we need to buy. And these are all the things which is getting used. Next. Next. And this is one of the very important, it used to be the cyclone. So whenever the cyclone comes up, today DTH is available or any other means of designation. There are days where it was not there for even authorities to take action. So ISRO along with the department, meteorological department, did all this work, but today it is not so much operational. In fact, we went to the extent of using the DTH set-top box to receive this, and whichever we gave a TV to the divisional commissioner who is responsible 24/7. you have a DDSL, our job is only ensure that he has a DDSL. He can watch whatever he wants. We ensure that he has that. But whenever there is a cyclone, from the Duration studios, we used to punch the corresponding signal. And whichever channel is that, he will come back to this particular channel and he will give us the information. So to that extent, it got modified. And then we thought that it may not be necessary to have a dedicated setup like that. So this is no longer functional because other means are available. But the point which I am trying to bring is, some of you have to take it test. Why there is such a system need not exist? You can question. If it exists, how it should exist? Definitely not the way in which we were running. It was a big project. Functional CH government question is not functional, things like that. But the job is done by other means. So when we improve, newer technologies are available. It is necessary we need to get up with that technology. Go to the next one. This is one of the very powerful service. This is a cross-loss SAT. In a disaster, there is no escape. Whenever an emergency comes up, this is what is getting activated. The details of emergency positioning indicator, all the seagoing vessels will carry this, and when there is an issue with respect to that, about good number of activities can happen. So that the vessel is being hijacked, or you are running out of fuel and things like that, and there is no connectivity with respect to your ICs, there is no mobile connectivity. You cannot carry the satellite phone because it's too costly for them to afford. And the first, in the disaster, if you press this immediately, you will be able to locate and then create. So that is about results. And it's also available in aircrafts. Aircrafts in such a way that the impact itself can generate this kind of signal. And when first, for example, any one of us want to go for the Himalayas mountain, we used to carry that unit. So they can activate so that we can locate. And this is a one-way information. And information is self-contained, and some of them using the Doppler effect we used to translate. And the control center used to be in India. It's a international system. And we have grown the payload. And fortunately, it also about 0.6 megahertz. And it's still functional, and it is getting innovated. And they say, this is the way we have grown in this particular part. The next one. Here, what happens is that geostationary satellite used to be the very, very important player here. Now, the world has changed over the view. There is medium of satellite, and the entire system is still functional. India is playing a very key role, and there are nearly 6,000 systems are established, and we take this entire region, not even India, beyond India, or versus Russia as well as Australia. So we are one of the major players in our INSAT satellite geostationary is carrying, and it is going to migrate to the new satellite, which is a low mass and Galileo GPS, and so far we have not planned for a new satellite. Because many of them, if you plan for a new satellite, our payload also can carry. So we have important players providing in this region this kind of a rescue operation, which is only way. And there are difficulties here. For example, they don't carry as long as the helicopter was running well, they don't carry properly. So there are faults we were not able to retain properly because they were not carrying. They are carrying that they never bother to check that it is properly maintained or not. All of them are there, but things are improving, and but this is one of the applications which has to grow as we stop contributing to a satellite-based communication. We should look into it, whether there is anything which you can contribute by mean that these are informations are available in public domain. So this is what we are providing for the satellite.
So maybe we can discuss if a typical number average of rescue missions that are.
Rescue is, I have up to 2018 about 48,000 to 47,000 lives per state in this particular region based on this. The way in which it works is, suppose if I am there in IC, I am hijacked, so I press that. The moment I press that, this entire signal goes to satellite, and we have a PNR, we have a hospital procedure. In the hospital procedure, I receive the signal, and I know where from data I will get it. The packet receipt shows clarity. The local laptop is coming as a product receipt. If we are having a older system, only we know about this available. Based on that, the doctor computation happens. We are able to accurately predict where it is going to be. The nearby ship, it is big. The destination system is very good. I will go to the Here, National Rescue Coordination Center, Regional Coordination, we have 4 centers, and then that is going to talk about maritime policy. Navy is involved, Coast Guard is involved, all of them will have. And we have a point of identification. So the moment I press, maybe 4 minutes or so, it is going to get notified from the Geo-system. Geo-system is a 43 seconds or something like that. And immediately, there is a 24 process, and information is disseminated to the MRC. It is a disaster, and any disaster is happening immediately. Highest office taken alert, and rescue mission start. And this is so perfect that it gets it well. As Prabhakar was telling, saving our life is very, very important. And we have a good number. And I don't have to vouch and produce why I did not put the number. It's internationally decided. No one is going to talk anything about going to have a system. This is the only system of it. It's only we need to find out how this can improve in national highways. Then there is an emergency happens. How can we extend this? And what all these which we need to do? If we are doing it in sea, if we are doing it in air, why not national highways? If you actually reaching and things like that, can we not do some system? There are system why I'm bringing up this is. Why I'm bringing this is because of this kind of a system probably is very important, and this is functioning better. And the future, as you enter into the field of SOC, you will be interacting with this kind of a system. It's an open information. The device manufacturing is open, and people can make, and qualifying this is also very difficult. And one can get into this particular development and get participation in this particular system. And it is one of the beautiful satellites that though it is less known, there are no companies. Very often we say when mobile comes up, what is the use for a satellite? And there are plenty of things which you can start thinking. And many of the activities a smaller group can work and try to bring up a commercially viable product. And the disaster tag is one which the derivative of the previous one, and this is predominantly given to the fishermen. This is not an international system, and based on the system, ISRO was working with the fishery ministry and our own development. And this is given to the fishermen because they can, it's possible for us to afford this kind of a system, but there is no talk back, so it is not coming back. And fishermen generally forgot to charge the batteries and things like that at all. So there are issues with respect to that. Otherwise, this is one of the very good systems. It provides the same rate information. If you get into information, you have to go through a normal level of regulation. Your cost goes up. You cannot distribute that. So we thought that it will make a very cost effective only for us. So we try to derive a small, like what we did in tele-medicine and tele-education. We have our own fishermen. It is now being modified. The second generation is coming with the Navi connected. We will hear in the next section how that is being done. So the next one. And this fisherman application also I will leave it to Mr. Nageshwar Rao who will be covering. So I don't want to cover. So it's possible that you can get to know how the fisherman is getting benefited by that. Go to the next one. And here is that another important aspect which I wanted to brief everyone in present here. The automatic identification system is one of the very unique, powerful applications that we call them as a thin row application. So what we talk about is a very voluminous data. If you talk about the video, if you talk about telemedicine data, it's all very in megabytes and gigabytes. And whereas here, the tracking system can be a very, very limited amount of data. So the automatic identification system which works on this particular galaxy, there are good viable model which is functioning, and with the same input it is possible for us to track many of the very important cargo. The moment it gets shipped, till the end user it reaches, it is being collected. So only information, but still it is very, very wise. And this information is very, very important for the country, and this one is getting that. And there are good amount of revenue model. So I cannot say a revenue model for all other applications other than telemedicine and tele-education. Villages was center normally will get that there is not much money. But whereas this has a good revenue potential, it has got all criteria, all characteristics of becoming another killer application. As they grow, this will become very, very important. Know this and ensure that one of you or many of you can look into the business and the current approaches. This is very good. the database satellites, I don't call it as an end user, but as we bring up the satellites of low Earth orbit and medium Earth orbit and both human space mission, there is a need for us to have the satellite which can talk to satellites and get us the data. For example, if I have a low Earth orbit satellite, because of its speed, it is going to create a difficulty of getting the connect with the satellite to put up our station in some other part of the country. But whereas we have a data-based satellites, the effective communication from satellite to satellite, as well as sitting here, we will be, for example, I will just tell you one example. If the aircraft of our VAP, when we say President or Prime Minister, goes out from here, if you want to track, you have to back on a foreign system. We don't have a system on board. Not of those days we were thinking very small. In fact, many of our work, at least my work was, initially we were convening only in India. We never looked at it. Now suddenly the world is open. If I have to provide a service, I have a lot of difficulties because my mind is thinking only with respect to India. So now what we need to do is that we have to take a very, it's not that tomorrow onwards I will start. We have to build. It takes about several years. There is another domain, how to build a worldwide system. It is same true for the navigation, it's true for the communication. Once you are confined to India, going away, it becomes very little. The point I am trying to tell is that the data-based satellite and US, Russians and Chinese have got a very good system. Basically, it provides the communication between LEO satellite as well as the human space band. It is absolutely necessary. And India is also getting that. We are going to two satellite. And this is one of the very important applications. I brought it here because though it is not the class of application that we are talking about, but still I thought if I don't touch other two applications cannot touch. So I'm opening a window for every one of you. The only point here I want to register is that at this point of time, there is another domain which provide inter-satellite communication. Sitting here, it's possible for me to provide a good level of comfort to satellite operators. It all done at the national level. It can be done by the private entity, but it has to be backed by the government because most of your activities will be intergovernmental activity and most of your consumers will be outside that. And so it's not a technical decision, it's a political decision as well. Go to the next slide.
Excuse me. Sorry. Going back to the previous slide, AIS system. The first of all, to mention the seagoing vessels. Can you extend them to the wagon movements?
The point is we are using 160 to 162. The protection for the frequency is available only in the seagoing system. They are relocated to the land or the services.
Okay. The land is available only for seagoing.
So the fact it is born.
Yeah, of course, the other GPS or Mavic is available for the land movements.
But you know, to do the satellite, and here it is very relevant, for example, after the mountain attack, we are trying to put this across, going the content, and expected they are doing. We are also trying, ISRO's is trying to do that. And all of them, today, no imagery, people are liking below AIS tag. It is not just to give an image. The image has to be tagged with what time and what is the quality, what is and the two places are very, very thick with respect to the maritime. I'm not about the international maritime. The coastal areas of near Tamil Nadu and Gujarat, where we have a lot of dinghies and tending to boats and things like that. Always we have border crossing and things like that. So these are all the system. Unattended one can be mounted. It is like a feeding, for example, you can go ahead with the GPS data.
But only when the individual vessels enables this.
That is where there are certain countries which successfully implemented. Like, they come and traffic police seize your vehicle if you don't have a license. So the postal authorities will immediately seize the vehicle and is given free.
If they catch them, they will see
them. So there are possibilities. And unless you do that, you end up in the data problem that you are facing. And it is a good, unique But AIS is very important because there are technologies which is available to use a frequency or multiple frequency and demand for electricity. That's not enough. If you start speaking to that level, then when we do that, we will try to do that. That's what they do. What is in a different form, what I call, all of them, the thin applications. If you tell them in this manner, they won't accept. If you call them an IoT technologies, they will accept. So this is all belonging new generation IoTs. They go to this side. And I think I try to rush through every 20 minutes the most important part what we should be doing. And so far what I tried to explain was that the kind of application what it has happened in this country so far. Now I just quickly run through with all the things that are being covered, so I'm not going to spend much time, so that I spend last 10 minutes on summarizing. You are quite aware of this body, that the newer generation of the satellite, we find that geostationary satellite. Earlier we used to tell about geostationary satellite means it's only for the communication. It's not about the satellites are coming for the communication. So that's why from the LEO, please note the point, the latency. The latency is one of the important things that geostationary satellite cannot do anything, and it has to live with it. So we find that the lowest orbit satellite are entering into the scene of the domain of well-established domain of geostationary satellite on that particular aspect. All other aspects are going to be, may not be that level, but definitely every one of us feel that if we have to get through the internet or things, the latency is very important. Though you covered all of them, I put this slide only for the latency part and we go to the next slide. These are all bands which we discussed, the L and S band when we talked about. Note the band, the Q and P band, in addition to KU and K band. KU and K band is today is available to a very big extent, and the Q and B band is emerging. So whenever you people are going to start your career and you are going to do that, you will be most likely working in KU, Q and B band for the high bandwidth application. And you will innovate with the L band and S band. Some portion of that K band is also being talked about as a potential moving on the vehicle on board with the L and S band. I will cover that a little bit afterwards, probably you may take over. Next step. And this is already discussed, so I want to touch upon. But for only two aspects. Aspect number one is the type satellite and onboard processing. And in our period, where about 20 to 30 years of experience of satellite technologies we talk about, onboard processing was one of the very big thing for us at some point of time. There were Space K in US who built the onboard processing and probe. And we also made, but unfortunately that satellite could not reach the orbit due to various other aspects. But we did not get into that. All our satellites were of in nature. But the people who are gone in that particular direction did not succeed to that extent. So to that extent we have not heard. And the idea is that the technology in the ground improves faster. So many of the things we are able to do it on the ground, so we don't have to do it on our phone. So with that, I don't want to deny a credit for that. Some of the technologies which is embracing today are trying to do some onboard processing, but there is a catch. So these two things, please keep your eye on that. This is already being discussed, so I'm not going to cover it next time. And this is also quite communication through satellite about GSAT station, the hub and all probably you are quite familiar, and I'm not touching upon the particular aspect. And various topologies which in your academics you could have done, and it was covered in my previous lectures by both people. Here is one of the very important. Those who are very much interested in the baseband, that is the electronics coming to the play and does the job. I have put various aspects of the hub station in this particular slide. These were all, they existed somewhere, some point of time, maybe 5 years back. These are all the technologies that is available. It did wonders. But this is going through a revolutionary change, and the way in which the work is necessary here is enormous. Based on the environmental condition, how we will try to change the coding, how we will switch from one format to other format automatically without ground intervention is a big thing which is happening, which I am going to touch upon. So this one particular thing is very important for the people who are working in the baseband. When I say baseband, the electronics, there is modulation, demodulation, without the ORM, prior to the ORM, we will be giving it in the L-band level. Up to the L-band, the software defined reviews and how you are going to do that is finding a phenomenal level of changes which is going to happen, and that is going to affect the GSAT industry as well as our other industry as well. Next slide. The system architecture is also slightly changing from normal satellite to a high throughput satellite. In the normal satellite, for the India, for example, if I consider in India, for the India shapability, we will have only one hub that can get connected to all. But the way in which you are putting it as spot B, to connect with the satellite, you need at multiple places. The hub is giving a way to gateways. For example, in this I am trying to put 4 gateways. They are nothing but a traditional hub station, and they have to be connected through the fiber. We are taking the help of our good old cheap neighbor, cheap hub gateway. So all 4 of them together give me a hub in the high throughput satellite case. And the user segment is going to be only with respect to that. So here the advantage is that you might have heard in your previous lectures. You can reuse the frequency so that the cost becomes cheaper. The satellite is going to be a little complex, but still that can be handled. And if this is going to make a cost-effective alternative in future for the terrestrial, it can be possible. Next. Now, next 5 to 10 minutes, I will spend my time, and after that I will clean any possible questions from you. And now, so far I was talking about domestic problems and the way in which it's a story of its own, and it's only to enthuse you. This is all the work which is done in the past, and the future is not going to be as simple as that. It is much more complex. I'll just talk about the one scenario. When the geostationary satellite which we find, it is useful still, but there are complexities with the alternative which is proposed, which we will be discussing. And the Geo constellation definitely has come to stay. The Elon Musk system, the Starlink system, is already 3,000 satellites are up. So much more satellites are going to come. There are one which even Indian private entrepreneurs are on, and is going to arrive. At least few of them are going to come. So we cannot ignore this particular activity. So Geo satellite we will be talking about. The transformation possibility of the ground system. The ground system is also going to be phenomenal level of ground system changes happening as we have seen last 20 years to now. It is a tipping point where it is going to take a huge toll in the ground system configuration. And the new opportunities, how it is energy, probabilities, all the things quickly we will talk about it next year. And I will be ending the slide at the end, but I am just continuing to you. The point here is that in the domestic operational system, I have already told you that diamonds, TV channels, and all of them in the first, it's already available. So you know the strength and when it is going to go, every one of you can hear check. Now the advantages, I have already told you that land, sea and land is going to be a very, very important application for satellite. It will continue to be no more things. So the satellite will remain to provide services to them. And the complementing the terrestrial system is what the reorientation the satellite communication people should take. And the rural and remote and the satellite mobile. These 3 points I leave it to every one of you to judge. You are the best judge, more than me or anybody else who is going to educate you. In your country, in your neighborhood, how the fiber is going to reach and how the village school or the primary school will get the benefits running in their system is your judgment. Based on that, you can be for or against the rural communication. Disaster management, as all of you know, in the world like there is no second. Now we are not, before coming to the focus areas, I am going to talk about the trends and specialist demand and go to the next slide. This is the history, right from the origin to 1988. They were all R&D in the period when they were trying. And in the last 30 years, government-run systems were in place. Most INSAT or US, Russian interest-putting, European Union, all of them were government-run systems, similar to INSAT. Now that is changing, absolutely changing. Come to the next. Here, small information for you. Right from the beginning of space age, up to 1960, an average of every year 1.3 satellites, and 70s 3.5 satellites. And after 2020, on average, we are only receiving 14 satellites. Only 1 year, that is 1967, so 143 satellites getting launched. But whereas, if you look at year 2020, about 400 satellites are getting launched, already launched. And then 2021, 1,778 satellites are launched. The prediction is that between 21 and 30, it's a pure prediction. Every one of you will appreciate that 1,700 satellites on average is going to fly. It is true, the way in which Elon Musk is launching the satellite and other satellites are going to come. So I will discuss about that. And about some 5 projects is alone taking 58% of the revenue. And to just go to an example, the Satellite Industries Association of 2020 talked about a revenue of 170.8 billion dollars. And as compared to that, I come to the next slide. This shows a better view of appreciation. The revenue of 386 billion is coming. Look at the first satellite services. The satellite services, this block, is what we are talking about, the EDH and things like that. That is the data of revenue. And if you look at the launch industry, it's a very small amount in terms of total revenue. But the revenue is going to be the application and services that we are going to go. That's what we discussed about that. So looking at this, very many players are jumping, and that is that, and everyone is saying this is not my data, this is American data, 2021 data, 22 January will get published, and the trend will be almost same. You can see the revenue for us. Next. The change that is happening in the geostationary satellite as compared to the national coverage, that is going to be the spot beam coverage, where the frequency difference is going to be used, and this will remain for various applications. And the next slide, the ground system also is going to be changed, because all of the beams, if you wanted to provide the ground system, you cannot handle at one geographical location. That is where you need multiple geographical locations. We call them as a gateway. So that the gateways are necessary. Here you have the hubs are necessary. So that is necessary for this entire set of geostationary satellite. For any reason, if it is going to continue, there is going to be a shift, and this is only going to be that, not the standard communication satellite that you have already used. Next one. I just wanted to give you a glimpse of what all the satellites in the last 8-9 years have come. These are all the satellites which has come up. India also has got its own satellite, the name of satellite. We started our own today, and we are trying to find the customers to go on. But the world has, I specifically put the area, the year in which it has got into. This is all satellite which is already up, and a good number of satellites is going to be announced or going to get into orbit, Jupiter 2, ISAT, all of them, there are big satellites. This is what I'm talking about geostation. The world is still continuing to keep one leg on the geostationary satellite. So the geostationary satellites are going to remain as it was, because it is proven and its own way it is cost effective as compared to the competing technology. So you people have to look into how this kind of high throughput satellite you can generate a new application in countries like India, where we have states, language, and things are different. Next one. These are all some of the satellites which has got a coverage belonging to the high throughput satellite. This is all again geostationary satellite. So the one point which I wanted to communicate in the satellite communication sector is that the high throughput satellites are coming. They are going to come in unimaginable data capacity, and it's covering the entire world, and people are investing money, and it's a proven system, and it is getting much improved with volume sale, and it's getting standardized. The next slide, is the one which I was talking about, the Leo constellation. If you don't know anything about this Leo constellation, then people will reject us, a person who is not aware of what is happening around the world. Because of that one feature, that the latency, which is not possible for the Geo, these kind of constellations are coming up. And this is not the first time that the world is seeing that. I put the listed in the year 2001, and sir was talking about alien constellation, ICO, Global Star, all these constellations were existing. But they were ahead of its time. They were not able to make a commercially viable system. And every one of them have got their own difficulties. They were existing in 2001. It's not that, in fact, many of you may not be aware. In that time period, Microsoft came with the TELUS consortium. And they were trying to make the watch system that the satellite they came from together. It is not that Elon Musk is doing today. It was done even earlier. But there were difficulties in which they were not able to achieve, which we find that it's possible for the rising people. The Starlinks is by Elon Musk. And one of the private independent from India has tied up with London-based organization. And Lightspeed is Amazon. Kuiper system, and Lightspeed is Telestar, it's a Canadian system, and then Kuiper. All of them, it is estimated that they together viable, the deep packets of that. Money is available, money is not an issue. They don't have to go to the any government or any private enterprise, they have good money. So with that money, it is possible for them to build a low Earth orbit satellite. I just wanted to quote a small example when LEO satellites of this kind will come out. 4,400 satellite, low Earth orbit satellite you have to fly. You need about 3,500 gateway antennas because of its orbital plane and orbital activity. And you need to set up 120 locations in the ground system. So look at the way the network management is going to come. It's mind-boggling number for about 4,400 satellites. So as against that, the gateway system in Geo. The coming days will prove, and many of you will be part of either one of these systems will take up satellite as a communication as one of the things. And as compared to geostationary satellite, is going to make a headway. And the biggest advantage is that they are holding the latency, which is 100% true. And satellites, geostationary, whatever we do on innovation, we cannot do. But the challenge here is the liability. And I just wanted to alert you, if you look at the stories of ATM, Global Star and Opcom, the Global Star and Opcom is continuing to be a very relevant organization. They are getting in the IoT space because the rate of bandwidth what they have, they can only run a small bandwidth application. They cannot support a 5 GB of an application. So this is one of the important aspects which, as you enter, you people have to innovate the way in which I was talking about tele-medicine and education. There are a good number of applications which we can list and we are working on it already ahead of us in India. Next slide. This is another comparison which I have put it across that the latency is being compared. Asian Development Bank, I just picked up from the Asian Development Bank. And these are all the kind of data being crunch upon. Still, the three domains which we are talking about. The first one is inter-satellite, how we are going to handle. How the constellations are going to be established, and it cannot be only for one country. It has to be a global. And only there is a business case. So you cannot be confining like the good old days and global service India. If you are going to get stuck, we don't have a starting point, and we will be left out. And as you know, some of the early satellites in the Ukrainian war, what kind of a penetration Elon Musk system had. And when Iranian issues have come up, and these satellites help them in a big way, no country can do anything with that. So the regulation that we are talking about, unless we are strong enough, is becoming very difficult. And another area which I forgot, maybe I will cover in the next slide. I will cover it across. And I wanted you to be aware of this comparison. This comparison is going to be very relevant. Whenever you open up the paper from today onwards, you start looking at a new satellite, you'll be moving around in this, trying to improve our understanding in this particular. Remember that two of the things in satellite itself, high throughput satellite and low Earth orbit satellite. The advantage and disadvantage. And the credibility established, the credibility is yet to establish. This is all anyone's thinking. Next slide. And this is one of the important aspects which many of you I thought you will be interested. When we have the low Earth orbit satellite coming up in that manner, so the coverage is footprint in the air is going to be in that manner, this is going to travel. So the calls, which is if at all if these satellites are directly going to provide the connectivity to your mobile. So the small majority of the satellite on paper, none of the satellites are providing direct mobile connectivity. but there is a thought in the public domain that there is a possibility that at least one constellation is thinking of providing. In case if they are going to provide that, you must understand that this 4 satellite and the geographical region when it is going to be done. The handing over, because the 90 minutes is the period of this kind of a satellite which is going to, because of the altitude in which it is placed. This is going to be of that region. And the call handover, like the way in which we are moving from one tower to another tower, how the calls are being handed over. To that extent, one has to do. And you all properly and you check. We haven't come across in the public domain so far. None of them provide, except that the Qualcomm chip is getting integrated into many of the satellite communication. Which means that as and when the order-related issues and these kind of inter-satellite communication and the good algorithm is written down, and you are able to overcome the frequency band limitation of LNS, you are able to achieve. There is a possibility that you will be able to reach that cost. But you can imagine if that is going to happen here, it's definitely not in the next 12 months or 24 months. But even in the drawing mode, they are finding it very, very difficult. So this is one area we can talk about the mobile satellite-based communication. Many of the satellites that we are going to discuss about are low orbit also. It is trying to address the latency issue. Other issue of coming to your phone and my phone is quite far away. And the full work has started, but all of them, whichever way you please go back to please say. And we come back again. There are few companies which is working on the direct-to-satellite mobile, which I will flag now. So those companies are really working on that, but their technologies are completely different. So the point which I am trying to summarize for every one of you is that these two satellite constellation, please remember, lower orbit constellation, these take up an advantage and more than task of managing, and human satellite, human satellite providing us an ability, and both of them are going to be slightly costlier than the terrestrial system as well, unless the launch cost and then the kind of redundant satellite and the satellite performance and the ability to not be able to communication, all of them are sure. Probably it will be up, but it is quite far away. As a professional, I can tell you that we are not finding that kind of a scenario that satellite phone provided by a Geo operator is going to be cheaper. That's not going to happen with this. But the height is that we need to segregate the revenue. As a professional getting into satellite communication, you need to look into that. Next. And another third dimension is that the key of this particular thing is done by the 5G group, 5G America. And it is no longer having seen this kind of a transformation taking place. The satellite communication is no longer looking at a geo or LEO. They brought in another unmanned aerial vehicle. And also, 150 onwards, we have another activity called high altitude, we call as a HAPS, high altitude platform. So there are two different layers of control. How to handle the unmanned aerial vehicle, which is have a dual purpose. And there are companies, Korean companies trying to operate their UAVs, and the border areas, armed forces trying to operate. And high altitude platform is that activity like a village festival. If you want to live, how it is good here, or Google has done such kind of experiment as here as Andaman Nicobar. So all of them are going to join as a part of our satellite communication. It's no longer a satellite communication. So the ground systems are fine-tuned. Standards are written in the ground system in such a way that if you try to make a modulation, demodulation, and coding, it becomes one standard order that can handle UAV activity, you can handle apps activity, and all other activities. And this is the open standard, like Android, it can become. So for that, the 3GPP, for this particular activity, the 3GPP release 70, this particular standard is going to define a very good number of applications stack where you can take and start building. Then you don't have to worry anything about to which market you are going to develop. And there are areas, for example, I put some of the pictures that traditionally we used to have a fluke GSAT, used to have an install GSAT. All of them are programmed like your DDH today you are operating on layer 1. And if you, for various reasons like mobile number porting, if you want to go from operator A to operator B, happily you can port it. But whereas in the DDH in your house, if you wanted to change over, you will say I need a different set of house. So similar manner, there are bottlenecks in the entire that. And then the kind of on state that the low noise block up converter and down converter, which used to remain in the GSAT, is also appropriate. We used to have a very manufacturer specific. Now that is also getting the normalization chain. They call it as a virtualization and digitalization. These two things are coming in a big way, as big as lower economic satellite and high-throughput. And phenomenal level of international actions are taking place. And we were not able to do it at that particular time because electronics industry was not that much mature. And we were not knowing how to make a volume market. Today, even the kind of things that COVID what we did, if you make it as a national mission, it is possible that this community has season as about 2 months ago. So people started building, and it is not any hardware at that scale. We are on the learning stages on par with other world leaders. So it is possible for us to take it across. And with respect to the antennas, we were having dish antennas of this scale. Even some of the dish antennas, it is not good to say, but I need to say that even some of the antennas for the INSAT are totally important. When we try to make it in India, the quality with which it is needed is a very small number. So if you try to take up to 2 antennas are not performing the way in which it is supposed to be. For example, you use a 65 centimeter antenna for receiving the DTH. Most of the things are borrowed from other agencies. Some are getting into that because the quality of volume pressures is what we need to learn. And there are very black kind of antennas which is going to assist the lower topics. Right? One of them is Kenta, which even Bill Gates has got a big stake of doing that. Many antennas, black kind of antennas are coming up. Those who are interested in RF side, please look into that lighter side of that. And it's smaller, and it should be light, and it should be compact, and it should be cost effective. If that happens, there is a good amount of your interference related issues getting resolved. And the BOGM already they have addressed. And the DVB-S to DVB-S2 standards are, you use your DVB set-top box, it uses DVB-S. And it goes up to DVB-S2X. So any one of you who are concentrating in a good future, and probably want to get into that. And advanced moderation and coordination, there is no end to it. All theoretical activities has to be coded and start implementing, and what is called as the automatic uplink power control has to be part of the software itself. So the hub, gateway and terminal, if it is trying to bring it together, it becomes that country. The last 4 things I am trying to put. These are all the people truly addressing their mobile, that is satellite mobile. One is ASP Space Mobile. They have launched a satellite called Blue Walker 3 satellite. Just 2 months back they are taking it across. And they are also finding the difficulty with respect to frequencies. They are trying to play around. And that is backed by the very well-known government. So we don't know how that is going to happen. And internationally there are issues with respect to regulation. We need to see how that is going to play out. And the SpaceX and T-Mobile, the company have joined together some of the SpaceX satellite is also getting direct to the mobile phone, and he has made a good thing with various other domains. So we need to keep awake and see what kind of a technology is going on. In case that is getting success, you must be in a position to switch to that bandwagon and start developing the system on our own as a very big country. So this is all the satellite, and the Nova is also all 3 of them are 5 on. And Global Star is a European constellation, is already existing, and they are also covering the satellite domain, and they are thinking into, but none of them is going to provide kind of replacement in the terrestrial, the kind of bandwidth. It takes like none of them, as of today, on paper also it is not there. So these are all the things, this is the ground system impacts, so the 4 things in the satellite communication that we need to talk about. High throughput satellite dimension, low Earth orbit dimension, the ground system, where the virtualization which is taking place. With all these factors, the new era is undertaken. Next slide. I tried to put this is my last slide. I will try to continue within 5 minutes. Now, what we just got, which is very, very important, we need to get from the international agencies. Though we are in a position to get all technologies, solutions, ability to meet is available. It's very difficult to get information. You have to be in the queue to get them. So there is a set of people who will do the job. The time to market, if you are very late, you will get ignored. So unless you are going to be in time to provide it, you lost the market. In any business, you have to be in time. What people need, you need to give. If you wanted a Netflix, if I am not going to provide from the geostationary satellite, I am out. I don't have a solution. Even people will come and say, okay, you give me only 9 to 5. There were days in this country where television channels were only active during the daytime. 9, 10, in fact, even satellite used to make a configuration that we used to jump. The power management, we used to save energy. That was the time. Can you imagine today I am going to provide a satellite which will work only in the daytime? It's not. So the satellite industry today based with the Netflix can you support, I have to say Geo-stationary anymore. So when this satellite can do it, make one. So when you make one, then we have 60 also, which I cannot look at India or I have to look at God. So these are all the issues which we need to take across. So time to market is very important. And any government, now it's not going to be government, even our government is also taking private entrepreneurs to do the job. So if you want to look at the test and then gradually grow, your entire constellation, you will go over the level of constellation. You should design in such a way that you start with 4 and keep on invading spring and start providing the service. So that kind of a thing is necessary, and the expansion is absolutely necessary. And GSAT design, one has to look into that. These are all the resources which we need to start looking at. And the banks, I have already told you what all the banks are available. And the payload, which are all important, the flexible payload of necessity. I'm sure that those flexible payloads are covered in the previous talk by the sets. And the serial, the beam configurable beams are going to be the very important aspect as we go along. And the features wise, the replacement satellite, even when you are planning for 5-year cycle, the replacement satellite should come in time. You should be ahead. You cannot say start providing the service. I lost 3 satellites, 1 satellite is comped off, so you won't get 2 hours, 9 to 5:30, you will not get the data. You will have so that is also necessary. And the collision avoidance, because there are reported incidents that in another 3 to 4 years from now, all satellites put together, which is now 4,000, 5,000, it may become 50,000 to 60,000 satellites. So just imagine the collision avoidance. This is its own area. So one has to look into that. And ground system wise, I have already mentioned 2 of the innovation and standards which is coming. This is very glorious things for every one of you to work on that. And along with that, the interference. So I have not talked about that much. I'm sure that that will be covered by other speakers. This is another biggest domain to the ability to predict the sources of interference and eliminate it and take mitigations in your functional satellite, whether it's the LEO or GEO, including the terrestrial interferences, becoming a bigger cost, and that itself is going to go a big market. So that means we have to take care. And then you already have addressed about handling large constellation. It is going to be a innovative task. And handling over simple, if you are going to provide the satellite mobile is also a very important thing. And satellite to satellite optical links. It used to be, I think, I'm seeing the last 6 to 8 months, there are good amount of solutions coming. So it's all published literatures, papers are available. And it's only a question of somebody sitting and embracing them. Most of the satellite, the next generation satellite or satellites are including them, but the first generation satellite don't have the linkages. If you have the linkages, it's easy for you to do the handling. The last one is simplicity. When you go through the satellite, like the way in which all the Institute of Medical Science systems were hacked, satellite also can be hacked. I don't know how many of you are familiar with the moment the Russian-Ukraine war started. The first thing Russians did was all the satellite models which are functioning legacy models. They were thinking the satellite models were one, which they can do anything. But when we catch hold of those modems they were generally from the Maya side. We can go back to the Google literature, and it was critical. But whereas when you try to make a system which is going around the world and which is your responsibility to ensure proper security so we can track, there are some very proven, I don't want to name them, the neural constellation, there are good documentation available. The people who are monitoring and producing the security, they were able to speak in the security of the Maya topics. So the people who are building also is aware that they have a weakness. So it's an agency. But what I'm trying to say is, like the interference, security is also going to become another important area, and one has to be. So this is all technology. So towards the regulation, this is all the things. Our outdoor process, our mobility systems, and data-based satellite, imaging satellite, all of them. This country we definitely need under our control. There's a reason government is also trying to find out a good number of private players. So that leads me the last slide. I'm sorry for taking so long. So I just came back to the same slide which I presented the last few minutes. I covered both of them and focus area wise. At the end of this lecture, I wanted only some clears to do. The ability to build flexible satellite, it could be LEO or GEO, that needs to be a greater level of understanding. It's not plain satellite communication that we are building. It is not a plain satellite that you are building. Whatever is getting imparted through these several courses are a starting point, and you must be able to do all of that. The ground system, you cannot make it as a proprietary and adaptable. And a good example is our Android. Android already is adaptable. To that extent, starting from the UAE to the HAPS, to the low Earth orbit satellite, to the Geo-stationary. To that extent, it is evolving, it is getting to the bandwidth. The application growth, you need to find out with all these features. It is not the job of a satellite maker or a ground system maker to find an application. You as a countryman here find out who needs and how much technology. So like the way in which we slightly innovated the tele-medicine and tele-education, those are only examples. Right from 70s, their organization was doing in this country. Now the onus is on the private entrepreneurs to take up, the startups to take up. And we must always ensure, we must recognize, the moment we recognize our advantages and disadvantages, it is easy to live in an environment. We must understand satellite technology can coexist with us. It can never replace the beautiful benefits this system has done. The 5G, we need to adapt, but we must ensure how we can coexist and how we can bring our advantages over that is there in the center. So those things we keep it and we have coexistence. Now the trends in advanced operation, advanced technology option, and new player and emerging ground system I already covered. And the specialized demand also, a very great extent to the satellite mobile and automatic identification you have done. Remember the narrow band. So try to differentiate an elephant with a mouse. Don't try to compare satellite mobile with the high bandwidth internet application. That has to be differentiated. And the next step is I will need to review the data-based satellite where we can communicate satellite to satellite, human space mission and things like that. It is a country's infrastructure, it is not individual infrastructure. Common will not get benefited as we grow bigger and bigger. And as a country where we have a national, international say, and we started chairing very many international committees as a country, it is absolutely necessary for us to get into the backend of data-based satellite and do everything sitting here. Around the globe. Any communication, anything which you want to do, you must be able to do. And along with this comes electronic intelligence, communication intelligence. This is a quite very complex area with respect to the armed forces involving all the tri-services. And there are a good number of technologies are being developed. We haven't covered, but I just wanted to alert you. The first year time I'm not able to touch those aspects. And there is a very tougher work at this government systems which we do. The audio is already doing something on that. And optical and audio space, and many of you have heard about optical communication and quantum communication. They are all the new niche areas which we will take care of. So the focus area are niche areas. This entire slide, I put it as a challenge because we have challenged in our period to a certain level. Now the world is presenting a satellite communication with a different. Now these are all the take up. If you are fully understanding satellite communication, whatever you talk about, it's only take a good foundation for it. And we are telling you with our experience where the world is going. Now it is up to you to take the next few steps, and I hope many of you sitting here will be part of this giant effort of the country and work through. Thanks for listening. Sorry for that. I never allowed any one of you to ask any questions for me. You can ask any questions. Because in my domain, I will tell you. And if something is not there, we will come back. And don't hesitate to ask any questions. The doubts have to be clear.
So, do you have any comments on Apple's implementation of this satellite mobile satellite communication with their latest implementation, the iPhone 14?
See, what happens is you have the satellite chipsets built into this particular satellite mobiles, which is adaptable to certain codings and certain encryptions. If you have to manage with the satellite, you need two components in this particular satellite. One is the on-off side, the antenna that can receive from the satellite. There you have to have the antenna which can take wherever you are indoor, you need to handle it properly. If you are outdoor, you have to handle it properly. So first you need to collect the signal, and then you have to process it. So for processing part, generally it is done. Why we have not succeeded too much in our satellite mobile is that the electron is becoming bulky. Now, one breakthrough has come is, at least I can name them, normally I don't name them, in this particular case I will name them. Qualcomm was working right from the beginning onwards on chipsets, which is adaptable to satellite. So the baseline portion of it is perfected and is being used by some 2-3 operators which I have told. They have been adapted right. Now, some of the manufacturers like Coke, there are published information available. They are already built into the baseline system. So as and when the all technologies are going, you know the 5G band. By now you know 5G band is a low end and mid band and high band. So the mid band and low band, 600 megahertz and 800 megahertz is a low band. 3.5 is the middle band. High band is a K band, which satellite community as well as rest of the community is fighting for. If these or many of the mobiles, you take a Samsung phone or something on the thing, so it's a limited channel, like called as a N78, N278. So the coding is something. So as and when the antenna on-off systems are being integrated, the baseline system, it knows apart from terrestrial, that's a chipset is also available. That is being done with the selected manufacturers. As you rightly said, some of the manufacturers, especially Apple, is adopting the chipset into the mobile. So the moment you overcome the proper order, with the result you have the direct satellite. For example, AST is going to adopt that technology. The handset becomes cheaper. Cheaper cost is not that cheap as it is. If it is going to be 1.5 lakhs to 2 lakhs per handset, those chipsets will bring down the factor of 2 years. So that is what will be achieved from the operation. Other than that, there is nothing like chipsets are being made. Would it be possible for you to visualize if satellite technology will be able to bigger nations are going to war? In fact, the way it becomes a reality, then humanity will be no, what happens is, generally the satellites, space-based systems are one of the two in the modern warfare, the tele-education. And it has proven in multiple places how the CNN during Baghdad war, their live telecast has helped us to evolve in building news channels to grow. When a war comes, the ultimate aim is to do. So my point is,
if satellite technology can potentially achieve that, no nation will ever be able to go wrong.
The question is that
Because the satellites are there up above,
right.
36,000 kilometers from the Earth. Somehow,
human is formulated. It's not a technology industry. So I also give my Ministry of External Affairs kind of understanding. So what happens is that there is no world policy. UN is supposed to do the job. UN, it is being put by respective things and data. So there is no the tools are available. How to use them? That's what is important. What kind of a tool we can make before the intercontinental ballistic missiles are fired, we can detect them and advance one. So who will do the job? If suppose, for me, the country is going to support me, I will be practically to that country. So the country has been instructed. But I don't think that there is strictly theory and solutions. Some other big solution is that
what is next step? This part is the world policy. That part is taken care of. Whether technology is
technology can work towards that, and then it's like, when you find the real thing, there is always an offshoot.
But satellite itself can be shot now. Satellite itself can be shot. From space itself we can feel other satellites.
So it's difficult.
I mean, still human is there, philosophically,
We can keep
human beings are there for the so without war, no technology.
So then that opens up a possibility that future wars will be fought in space.
That is very well. It's not itself.
That is very
India itself, we have a space station.
Now we have space forces there.
Space forces there. Last year it was established. It existed for a while. It was important. In fact, like in ISRO, we have our own agency.
The all of technology is given by war only. All technological developments are given by war only.
Correct.
I just have a follow-up.
So it is billions of dollars.
It's a huge business, nobody will use it.
No, satellite, to put it shortly, satellites cannot be a deterrent for the war. In fact, it will be a aid for them carrying out of the war. And as he said, the world police, who is respected by all the satellite owners, they can be disciplined enough to use the satellite for peaceful applications, not for destructive applications.
In fact, I will tell you, in Geneva, we were talking about the IT aspect. There was empowerment each country to empower them. If they find any object, they can take it away with the help of the selected countries. So no country accepted. They cannot do this kind of thing. They are not empowered. It's only regulated because they will come to a common understanding. It's almost like an audit. Tells you, if you do like this, you are good. In fact, if you violate, many countries violate. So it is not possible for us to have something of that. The political environment around the world is something like that.
I just had a follow-up to what you said. Why now? Since Apple is much time to embrace satellite communication. Was it a cost factor? Was it a regulatory factor? Yeah. What has satellites in case of emergencies? Trying to integrate it into a personal mobile. What was the latency?
Yeah, there are two things. I was trying to address electric and for the satellite, you need the adapter impact. Is it kept as specified in the satellite? And the ground system, the antenna, especially the RF system, is only we can make it as a compact. That's now, for example, see that in the image. I cannot make it as an actor because of the technology. First of all, the current antenna. And the number two is that the bandwidth is demarcated as a level that is very small. 20 megahertz. This is about gigahertz, about 100,000 megahertz, we can add all of it. Whereas the
the demarcation of the L-band and S-band is and second one is technologically for the satellite we see in the S-band and satellite. Despite of having a 6 meter, in fact, Kasha is an external 6 meter GSAT satellite. Alpha level antennas which you have to build. 6 meter to 16 meter is a little bit really what you need is a big antenna. It does not use one complex. It is sometimes it is not possible. So to shortlist major things, one is that the limited time the ground system and the satellite that we are going to build. Also it is not going to be feeding into replacing this one. Because here you are going to see for example you assume that you have a tower. You want it 20 hours. And about 20 kilometers we are traveling. The same 20 we are doing from satellite S-band and L-band. I know this before, expressed thank you to get it that whether it is possible from the satellite to use them, like the way we use K band. You do the external one part, then you have to activate the other part. That how kind of using safe, if not talking, that's another. These two things were very different, not to be. In other cases, we are not alone. In this, we are not alone.
We have to set up a Satcom system from scratch, be it with respect to INSAT or tele-medicine. As you said, in one particular district, that was the first computer that I was using. So, what are the key technological challenges as well as the cost for technological components, the cost for setting up such a system, and how can it be
when we started looking at this, we were trying to see whether we can increase the industry to make the ground system. But it was not possible to put the whole GSAT system is very cost about 40 exactly. But the 40,000 is 1 million per annum. So you have to consume that much. So that is why if you see in today's arena, there are only two companies which we can talk about. One is ISRO and another one is SCPO. Other than that, there is no play. So they are producing for the whole market. So if you have to scale up to that extent, if the task is given to you, like the way we usually believe the chips for the coin, the way in which energy will must what the cost and what we buy it. That kind of a national mission, if you take it for addressing the inflation requirement as part of our requirement, that is a possibility. But otherwise, technology-wise, we are focusing on the people who did in intercontinental university and things like me and science and medical sector. It's not going to be a tough journey. The chipsets are possible for us. But volume is important.
Any other questions?
Sorry, I did not give time for you people to ask this question. Sorry.
How do we prevent data loss in communication?
Data loss. See, standard techniques of the error detection of all those things are being and this is the point. Many of you would have talked about the link engineering. The way in which you are going to connect your data to reach the satellite and reach the other end. The whole data link, the link engineering you have to master, you have to provide a sufficient margin at both the places. Once you have built, then you are ensuring the data get originated from here and it passes through without any losses, any corruption. And then the interference which I was talking about, when you go through the satellite, you may be doing everything properly, but the other neighboring fellow may not be doing a proper job. So you must be able to detect that and then take care. With all of them factoring into that one, you will be able to communicate back from the satellite to the ground system. The baseband system which I have put one slide, where the adaptive coding system is able to detect, and even without your knowledge, it will retransmit those packets and try to continue like the way TCP/IP is doing with the UDP and TCP protocols. Similar way, the baseband system, the software is built into that. But problem remains that we can't do beyond certain level. Whatever you are able to do from one end to the other end, what all technologies that you are adopting, same technology only is going to be available. Whatever the optical network communication, whatever you are going to communicate, the same thing. For example, in terrestrial communication, you would have used a TCP windowing system. When you use a TCP windowing system, it is assumed that when it goes through the various hops, it is taken care and replay attempts and reconnect calls or issue. When you go through the satellite, you should anticipate the accelerator. Prior to the TCP, there is an accelerator. The accelerator will inform you that it is not a terrestrial communication, it is a satellite communication. Minimum time is respect. So you have to correct it across is what we build into the system. So those systems also to take care. Beyond that, whatever terrestrial communication system you are doing, the error correction and error coding which you are doing, same thing will be applicable for the satellite as well.